This is Design Safe Radio, where natural hazards researchers strive to make our society more resilient to everything nature throws at us.
Hello, welcome to another episode of Design Safe Radio. I'm your host, Dan Zahner, and if you couldn't tell by the background today, we are talking about coastal engineering with Dr. Nina Stark, who I'm really excited to see. We've been colleagues for, it's been 9 years now?
Yeah, more, I think, yeah.
But it's great to have you from the University of Florida. Tell us a little bit about yourself, and then we'll get going in with some questions about your really amazing research.
Sure, I'm an associate professor in the Department of Civil and Coastal Engineering at the University of Florida. And my research is really in between the fields of geotechnical engineering and coastal science and engineering. So I'm interested in coastal processes, but I look at them from a geotechnical perspective. So I'm interested in soil mechanics and how sediment moves and why it moves and how it responds to stresses and loads. And I do that in underwater environments, sometimes rivers, but mostly at the coast and in not too deep in water depths. And in that regard, we are also encountering quite a bit of hurricanes, other storms and floods. And so naturally, this topic of natural hazards is playing quite a significant role in my research. Other than that, my research also includes quite a bit of fundamental work with regard to trying to understand the connections between erosion and geomechanical properties, as well as we are contributing quite a bit to different civil engineering applications, as well as naval applications, such as unexploded ordnance site management or trafficability.
Wow. Yeah. You're one of those people who are like the epitome of a NEER researcher. You've got a lot of different disciplines going on, a lot of different varied expertise. I keep looking at the schedule and seeing your name pop up and all sorts of interesting collaborations. So it's always fun to hear what you're up to.
Yeah, absolutely. I think that also comes with the field. So I'm truly convinced that these problems cannot be solved with one perspective in one discipline. So naturally, we are involved in a lot of multidisciplinary projects. And, sometimes we don't even know yet what kind of disciplines we really need to solve these problems, right? So that's, I think, how even if we are maybe right now not working with a certain discipline, that doesn't mean in 5 years we may not be working with them anymore. We start working with them. And so I think that is really a very intriguing part, in particular of the type of research we are doing. So I work with a lot of different people who have very different perspectives on the problems. And the really cool thing is that we are all working together to really joint goals of improving safety and resilience of coastal communities from natural hazards, as well as I mentioned, solving other engineering problems in civil engineering with regard to infrastructure, as well as other applications.
Yeah, and one of those collaborative efforts that you're part of, we've talked about, I think the last time we had somebody from one of the extreme events research groups, probably Tracy Kajewski-Correa, way back. But these are formal National Science Foundation supported groups that are dedicated to collecting this perishable data. Can you tell us a little bit about you're in, I think, two of them, the nearshore and geotechnical, which we'll refer to NEER and GEAR from here on out. Give us a little bit about those guys, and we'll dive, no pun intended, into that a bit.
Sure. Yeah, sure. Let me maybe start with GEAR. So as far as I know, GEAR is actually is probably the first of what we often refer to as the EARs, the Extreme Event Reconnaissance Association. So GEAR exists, I don't want to bet on it, but I think since the 90s, and started actually focus on earthquakes. And so geotechnical engineers from practice, academia, and federal agencies came together and built this group that practically comes together when extreme events happen to collect data that will improve our understanding of the mechanisms, what is happening during these extreme events, and then how does it come to these impacts, and what can we do about them in the future and improve it. have done so since then and have really expanded in different extreme events that they have tackled, as well as in membership. I don't have the exact numbers, but I think GEAR has actually quite substantial member base of geotechnical engineers from, again, academia, practice, and federal agencies, and the different perspectives, again, become really important here for these events. And then later on, and again, I don't have the exact times, but so different ears started to form, focusing on other topics. And NEER, so the Nearshore Extreme Event Reconnaissance Association that I'm also affiliated with, is kind of unique in that whole world as well, since they are not so much focused on a discipline group, but on an environment. So the idea is really to be focused on the coastal zone and the nearshore zone, but bringing in people from a wide range of disciplines to actually look at these impacts. And so these associations, by actually having that network already, I think a key thing, in my opinion, is since the network exists, it's so much faster in communication amongst all these experts to actually get going, get on the road when these events happen, to make a plan and get out there and get this data. And you mentioned perishable data before, so that's really important. So I think something that would otherwise be really difficult is, so if you're thinking about a typical research effort or even just an engineering project, right? So they're typically being planned. There's a long planning phase, and then they go into actual action of data collection or construction. But so there's quite some time, right? And with these extreme events, we often don't really have, or we typically don't have that planning phase because we don't really know, right? I mean, we don't know when they occur and where. Maybe we have an idea of, obviously, of vulnerability of certain places to certain extreme events, as well as maybe a timing if we are thinking about hurricane season or so, right? We have kind of an idea of where and when, but until actually something becomes a little bit clearer, we don't have really the option for detailed planning there, right? So it's all at very short notice. And even then, earthquakes are even more extreme case for that, right? So you are fully reactive. But staying with the storms, for example, you can plan to some degree, but not fully. And so these groups, by having the network, practically enable a quicker communication. And the perishable data is important, since not only these events are occurring kind of unplanned, but we obviously have to prioritize the health and the well-being of the communities, right? So we cannot say we have to keep the status quo after an extreme event just so that we can collect data whenever we are ready to collect data. But we have to collect the data pretty much parallel to cleanup work, to repair work that are really essential. But also there's not natural processes that will actually change possible observations, right? So it is important to really get there and collect this data immediately after these events, and if possible, sometimes even during these events, so that we actually really get a comprehensive data set. And that is really this perishable data, right? The perishable data that is being lost if you cannot get there and collect that data at a certain time.
Yeah, it's because these communities, whether it's a hurricane or an earthquake or a landslide, they're wanting to get back to normal life and clean up
absolutely.
debris and move sediment off of roads and clean up spiders and all sorts of other fun stuff. Washed on shore, or remember back in, this was a long time ago, Hurricane Harvey. You just get all sorts of stuff pushed around, and they're just trying to clear roads. So the research community wants to know, fundamentally, how are things like bridges and signs and billboards and hotels and all the things that make up our world, how do those react? And your spot there in the near shore is really interesting, because as you mentioned, it's not focused just on the wind side, it's not focused just on the waves, but it's the environment. How do you collect some of this data? Because it's such a wide variety of disciplines working together. What kind of instruments do you use for that? What kind of data are you collecting?
Yeah, so I typically think in four big pillars that are kind of overlapping. So one is really topographic or bathymetric data. So thinking about processes like erosion, right? So how does actually the geomorphology change? Where are we losing land? Where are we maybe gaining land because the sediment that was eroded in one place is ending up there? We had, after Hurricane Irma, a really great example where we had one house that was pretty much destroyed by scour and erosion, and the other house was destroyed by deposition because all the sand actually ended up there. So
Wow.
understanding actually how the sediments are moving, getting eroded and deposited somewhere else, and it's not only traditional erosion, it may also be mechanisms like slope failures and others. It is a really important part. So that means actually measuring the topography. And if you're in the coastal zone, that means not only on land, but ideally also in the water, because otherwise you're always missing a part of the puzzle, right? So it's important to do both. Gives a good idea of, okay, where did we actually lose land? And that may actually impact infrastructure, right? Like scour, if we are eroding sediments, right, at infrastructure systems, we are possibly weakening their foundations and so on. So being able to monitor that and understanding why did that happen in that spot and not in the other spot is really important. So topographic data, bathymetric data is one really important component. Another one, what are the forces really driving it, right? What is really bringing in the energy? So looking at your background here, right? Waves, storm surge, but also currents, right? If you're thinking about a storm surge pushing on land, it's squeezing between these houses, right? And or it may even like go under roads, right? And going through the soil, creating some internal erosion, or creating little tunnels and scouring out things again, right? So actually understanding what are the driving forces is really important. So water levels, so traditionally that would be often like that and we still are doing that, looking for high water marks, right? At houses or infrastructure where we see how far did the mud get up there and things like that. But nowadays we have new sensors that they're not that new, but I think it's getting newer that we are deploying them throughout these extreme events and that they're more rugged. So actually measuring what are the waves here right on this spot, right? And what was the storm surge right here are really important measurements to understand what was really the driving force.
Thanks for listening to today's episode of Design Safe Radio. Be sure to like and subscribe on whatever platform you happen to be listening to this on. It really helps people find our show. Thanks to our amazing sponsors, the National Science Foundation and the NEER Network Coordination Office, which is award number 2129782. Big thank you to Marty LaChance, our guest booker and topic researcher extraordinaire, and Raquel Ruiz, who is our video and audio editor. I'm your host and NEER Facility Scheduling and Operations Coordinator, Dan Zahner. We'll see you in the next episode. Until then, stay resilient.